So in this video, we're going to talk about how to solve radical equations with two radicals. So when you're solving equations that have more than one radical, you're going to start off by separating the radicals. You're going to rearrange the problem so that the radicals are on opposite sides of the equation. Then you're going to raise both sides of the equation to the opposite power to eliminate the radicals, then isolate the variable to solve, and then check for any extraneous solutions. So let's start off with this example. You can notice that the radicals are already separated because they're on opposite sides of the equal sign. So I'm going to undo the radicals by squaring both sides of the equation. So when I do that, I get 2x minus 5 equals x. So now to solve for x, I'm going to collect all my variable terms on one side of the equation. So I'm going to subtract 2x from both sides. And now I get negative 5 equals x minus 2x, which is negative x. Remember that a negative x is basically a negative 1x. So now to solve for x, I'm going to divide both sides by negative 1, which gives me 5 equals x. So I'm going to go back to my original problem and plug in this value of x to see whether it makes the equation true. So that gives me 2 times 5 minus 5 equals the square root of 5. So that simplifies to 10 minus 5 equals 5. And I do get the square root of 5 equals the square root of 5, which is in fact true. So that means that x equals 5 is a solution to this equation. So now you can go ahead and pause the video and try this example on your own. So in this example, the radicals are already separated, so we're going to square both sides and then solve for x. When you solve for x and get the value of x equals 4, you'll see that plugging it back in does in fact make the equation true. So now let's try this problem. So once again, we have our radicals separated on either side of our equation. So we're going to raise everything in our equation to the opposite power. So notice that in this problem, there's a 3 in front of the radical on the right side of this equation. When I square it, I'm actually going to square both terms on the inside. This is that product of powers property. When you have ab to the n, that means you have a to the n, b to the n. It's almost like the power distributes. So that means that on the left side I have x plus 7, but then on the right I have 3 squared, which is 9, and then 9 times x minus 1. So now to solve this problem, I'm going to start off by distributing the 9. So I have x plus 7 equals 9x minus 9. Now I'm going to collect all my variable terms on one side by subtracting 9x from both sides. So that gives me negative 8x plus 7 equals negative 9. Now I'm going to subtract 7 from both sides. So that gives me negative 8x equals negative 16. I'm going to divide both sides by negative 8, which gives me x equals 2. So now that I have x equals 2, I'm going to plug back into my original equation and make sure that it makes the equation true. So I have the square root of 2 plus 7 equals 3 times the square root of 2 minus 1. So that gives me the square root of 9 equals 3 times the square root of 1, which does in fact tell me that 3 equals 3. So that means that x equals 2 is the solution to this equation. So now you can go ahead and pause the video and try this example on your own. So remember, I'm going to start off once again by squaring both sides of the equation. So I'm going to square the 2 along with the square root of x plus 2. So I'm going to distribute the 4. When you solve for x, you'll get x equals negative 1, and you will find that plugging it back in does in fact make the equation true. So now let's try this problem. So once again, we're going to start off with our first step. We want to separate the radical. Well, in this problem, the radicals are not separated because they're on the same side of the equation. So what we're going to do is we're going to take this radical term and we're going to move it over. Remember, whenever I move over something to the other side of the equal sign, I have to do the opposite. So here I'm subtracting the square root of 24 plus 2x. So I'm going to do the opposite, and I'm going to add the square root of 24 plus 2x to both sides. So that's going to cancel this term on the left, which is going to leave me with the square root of x squared plus 7x equals the square root of 24 plus 2x. Now that I've separated these radicals, I can go ahead and now take the square of both sides to undo the radicals. So I'm going to square everything on either side of this equation. So that gives me x squared plus 7x equals 24 plus 2x. So notice now this is just a quadratic equation. Remember, I always need to set my quadratics equal to 0 before I can solve, right? We want it to be in ax squared plus bx plus c equals 0 form before we can solve. So I'm going to take these terms over to the other side, starting with a minus 2x. Remember, that's going to combine with a 7x because only like terms can combine. So I have x squared plus 5x equals 24. Now to get this equal to 0, I'm going to subtract 24 from both sides. There's nothing for 24 to combine with on the left, so I'm just going to leave that as x squared plus 5x minus 24 equals 0. So now I'm going to work on solving this quadratic equation, and I'm going to solve this one by factoring. So I have a negative 24. Remember, when I have a negative number, I need a positive and a negative number to be the factors. Since 5 is a positive number, right, I want my factors to add up to b. So since 5 is positive, I'm going to make my bigger factor positive factors. So let's list out all the factors. So 24 has factors of 1 and 24, 2 and 12, 3 and 8, 4 and 6. So I'm going to leave the bigger factors positive and make the smaller ones negative. So when I add up my factors, negative 1 and 24 gives me 23. Negative 2 and 12 is 10. Negative 3 and 8 is 5. And negative 4 and 6 is 2. So negative 3 and 8 is going to be the correct combination of factors. So when I write this as a factored equation, I can say that x minus 3 times x plus 8 equals 0. Now, using the zero product property, I'm going to set each factor equal to 0 and then solve. So I have x minus 3 equals 0, which gives me x equals 3. And then I have x plus 8 equals 0, which gives me x equals negative 8. Now I need to go back to the original problem and double check my factors. So I have the square root of x squared plus 7x minus the square root of 24 plus 2x equals 0. And the two values that I'm going to check are x equals 3 and x equals negative 8. So if we check 3, we have 3 squared plus 7 times 3 minus the square root of 24 plus 2 times 3. I'm checking if that equals 0. So we have the square root of 9 plus 21 minus the square root of 24 plus 6. And this tells me that the square root of 30 minus the square root of 30 equals 0, which is in fact true. So that means that x equals 3 is a solution to this equation. Now let's try x equals negative 8. So we have negative 8 squared plus 7 times negative 8 minus the square root of 24 plus 2 times negative 8. Checking if that equals 0. So we have the square root of 64 minus 56 minus the square root of 24 minus 16 equals 0. So that tells me the square root of 8 minus the square root of 8 equals 0, which is in fact true. So that means x equals negative 8 is also a solution. So we actually have no extraneous solutions in this problem. So now you can go ahead and pause the video and try this example, which is very similar to the one we just did. So once again, you're going to add the square root of 32 plus 2x to both sides to get the radicals on opposite sides. We're going to square both sides, and then we get a quadratic equation, which we work on setting equal to 0. Once we set it equal to 0, we have negative 32 as our c term. We're looking for two factors of negative 32 that add up to 4. Since negative 32 is negative, we're going to have a positive and a negative factor. Since 4 is positive, our bigger factor is going to be positive. So the correct combination of factors that we need to do this is negative 4 and positive 8. So we have x minus 4 times x plus 8 equals 0. When we solve, we get the two solutions, x equals 4 and x equals negative 8. And then when we plug back in, you'll find that both of these solutions make the equation true. So both x equals 4 and x equals negative 8 are both solutions to this equation. So now let's try this example. So once again, we have our radicals together on one side of the equation. So we need to work on separating them out. So I'm going to do the opposite, and I'm going to add the square root of x plus 5 to both sides of this equation. So when I do this, on the left, I have the square root of x plus 10 equals 1 plus the square root of x plus 5. So now I'm going to use the same strategy that I've been doing, and I'm going to square both sides of my equation. When I square both sides, on the left I have x plus 10, but then I have something different on the right, because on the right I have a sum that I'm squaring. Remember, whenever you have a sum that you are squaring, it's a good idea to use FOIL. You can use FOIL or you can use the box method. Either way will work, but I'm just going to show you with FOIL. Remember, we're going to multiply the first term, so we have 1 times 1, which is 1. Then we're going to do the two outside terms. So we have 1 and square root of x plus 5. 1 times the square root of x plus 5 is going to be the square root of x plus 5. The inside is going to be the square root of x plus 5 and 1. So that once again we have the square root of x plus 5. And then the last term is going to be the square root of x plus 5 times the square root of x plus 5. Well, when you have anything times itself, remember that's the same thing as squaring it, right? So this is basically telling me I have the square root of x plus 5 squared. Well, squaring something under the square root is basically the opposite operation. So this is just going to be x plus 5. Remember, the final step in FOIL is to add up all our terms. So all my terms are going to be 1 plus the square root of x plus 5 plus the square root of x plus 5 and then plus x plus 5. So let's combine our like terms and simplify this down. Well, I have the square root of x plus 5 and the square root of x plus 5, right? So I have like 1 square root of x plus 5 and 1 square root of x plus 5. So that's going to be the same thing as saying that I have 2 square root of x plus 5, right? Because 1 plus 1 is going to give me 2. Then I have x plus 5. And so now I'm going to look for any more like terms. The like terms I have are this 1 out here in front and this 5 I have at the end. So if I combine them, I have 6 plus 2 square root of x plus 5 plus x. So I'm going to plug this back into that problem I was working on. So 6 plus 2 square root of x plus 5 plus x. So now we need to work on rearranging things. So notice that once again, I have a radical equation, right? So even though I squared both sides, I didn't get rid of all my radicals. So we're going to go back to our strategy that we've been using and we're going to work on isolating the radical. Okay, so now that we have a radical, we're going to work on getting that radical by itself. So I'm going to move everything away from the radical, starting with this plus x. So I'm going to subtract x from both sides. So doing that gives me 10 equals 6 plus 2 square root of x plus 5. Now I need to move away this 6, so I'm going to subtract 6 from both sides. So I have 4 equals 2 square root of x plus 5. And now finally, I'm going to move away this 2, so I'm going to divide both sides by 2 because that 2 is multiplying the square root. So that's going to give me 2 equals the square root of x plus 5. So now that I have 2 equals the square root of x plus 5, I can undo the square root by squaring both sides of this equation. So when I square both sides, I get 4 equals x plus 5. Now finally, I'm going to solve by subtracting 5 from both sides, which gives me negative 1 equals x. Well, I still have to check my solution, so I'm going to go all the way back to the beginning, and I'm going to plug into the original problem itself. So I had the square root of x plus 10 minus the square root of x plus 5 is equal to 1. So when I plug in, I get the square root of negative 1 plus 10 minus the square root of negative 1 plus 5 equals 1. So that's the square root of 9 minus the square root of 4 equals 1. Square root of 9 is 3 minus the square root of 4, which is 2. And 1 does in fact equal 1. So x equals negative 1 is the solution to this equation. So now you can go ahead and pause the video and try this example on your own. So this problem is very similar to the one that we just did. So what we have here is we have the radical that we need to separate. So we separate the radical and then square both sides. When we square the right side, we're going to have to use FOIL. So you expand this out and then you combine like terms, which gives us 10 plus 4 squared of x plus 6 plus x. So we have that on the right side. And then what we do is we start moving over the terms to start isolating the radicals. So we subtract x from both sides, then we subtract the 10, and then finally we can square both sides in order to undo the radical. So when you square both sides, in this problem on the left side, you actually have a binomial. So we use FOIL to expand it out again. So that gives us 4x squared minus 16x plus 16 equals 16x plus 96. And then since we have a quadratic, we need to set it equal to 0 to be able to solve. So we go ahead and move all our terms to the other side so that we have it set equal to 0. So then we have 4x squared minus 32x minus 80 equals 0. So we need to factor this equation, but when we factor, remember you always want to check for a GCF first. Notice that 4 will evenly divide these three terms. So I divided everything by 4, which left me with x squared minus 8x minus 20 equals 0, and then I divided both sides by 4 to cancel that out. That left me with x squared minus 8x minus 20, which I can then factor as x plus 2 times x minus 10, right? I need two factors of negative 20, so I need a positive and a negative factor. Since the b term, negative 8, is negative, my bigger factor is negative. So the correct combination is 2 and negative 10. So when I have x plus 2 times x minus 10 equals 0, I solve for x and get x equals negative 2 and x equals 10. When I plugged both solutions back into the original problem, it showed me that x equals negative 2 gave me an extraneous solution, right? Because it said that negative 2 equals 2, which is incorrect. And then when I plug in x equals 10, it does in fact verify in the equation. So x equals 10 is the solution to this problem. So now let's try this example. So once again, this has a radical in it. Remember, our idea is always to try to get the radical by itself before trying to undo it. So here I have a plus 8 with my radical that I'm going to undo by subtracting 8 from both sides. When I subtract 8 from both sides, it leaves me with the square root of x plus 4 equals x minus 8. So now I need to square both sides to undo this radical. So when I square the left, I have x plus 4 equals, on the right I have x minus 8 squared, which is x minus 8 times x minus 8. Once again, I'm going to use FOIL to expand this out. So I have first times first, which is x squared. I have inside and outside, so outside gives me 8 times negative 8, which is negative 8x. Inside gives me negative 8 times x, which is negative 8x. And then last times last gives me 64. I'm going to add up all these terms, so I have x squared minus 8x plus 64, which gives me x squared minus 16x plus 64. So I'm going to plug this back into my original problem. So notice that once again, I have a quadratic. To solve a quadratic, remember I want to set it equal to 0, so I'm going to move away my terms one at a time. So this x, I'm going to undo it by subtracting x from both sides. So I have 4 equals x squared minus 17x plus 64. I'm going to get rid of the 4 by subtracting 4 from both sides, which gives me 0 equals x squared minus 17x plus 60. So now I need to work on solving this quadratic. So I have x squared minus 17x plus 60 equals 0. So my value of c is 60. Okay, 60 is a positive number, so I either need 2 positive or 2 negative factors. Well, b is negative, so I need 2 negative factors. So let me list out the factors of 60 and make both negative. So I have 1 and 60, 2 and 30, 3 and 20. I'm out of room here, so I have 4 and 15. And then I have 5 and 12, which are both negative. And notice that negative 5 and negative 12 will give me the sum that I need, which is negative 17. So that means when I factor this equation, I'm going to have x minus 5 times x minus 12 equals 0. So that means that either x minus 5 equals 0, so that means x equals 5, or x minus 12 equals 0, which tells me that x equals 12. I'm going to go back to this original equation. So I have the square root of x plus 4 plus 8 equals x. And I'm going to plug in these two solutions that I have, x equals 5 and x equals 12, to see which one makes my equation true. So when I plug in 12, I get the square root of 12 plus 4 plus 8 equals 12. So that's the square root of 16 plus 8 equals 12, which tells me that 4 plus 8 equals 12, which is in fact true. Then I plug in 5, so I get the square root of 5 plus 4 plus 8 equals 5. So the square root of 9 plus 8 equals 5, which tells me that 3 plus 8 equals 5, which says that 11 equals 5, which is not true. So 5 is my extraneous solution. That means that x equals 12 is the only solution that will make this equation true. So now you can go ahead and pause the video and try this example, which is very similar, on your own. So in this problem, I added 5 to both sides to isolate the radical before squaring everything. Remember the x plus 5 squared, I have to expand it out using FOIL, so that's how I got x squared plus 10x plus 25. Then I worked on getting the quadratic set equal to 0 by moving away the terms. So that gave me x squared plus 14x plus 24. 24 is positive and so is 14, so I know I need two positive factors. When I listed out the factors of 24, 2 and 12 gave me the correct combination, so I have x plus 2 times x plus 12 equals 0. Setting these factors equal to 0 gave me two potential solutions, x equals negative 2 and x equals negative 12. When I plugged both back into the equation, x equals negative 2 did in fact make the equation true. However, x equals negative 12 gave me a solution of 2 equals negative 12, which is not true. So that's why x equals negative 2 is the only solution, and x equals negative 12 is an extraneous solution. So in summary, remember, when working with equations with more than one radical, you're going to start off by separating the radicals. Rearrange the problem so that the radicals are on opposite sides of the equation, and then raise both sides of the equation to the opposite power to eliminate the radical. Then you're going to isolate the variable to solve, and then you're going to check for any extraneous solutions.